if you go back to normal worlds,
yeah.
In your calculator, you want to change the base to find an answer.
Yeah, what do we do?
However, the log and then the well, in this case, x over log the base.
Yeah.
2.
So if you want to use a log and try and calculate it in another base, your calculator doesn't have another log base button, right? So we learned the change of base formula. And what was that for this particular situation? How can we write y another way? What did you write, Kyle? Log x over log 2, which is correct, except we should be writing what base we're using. E is preferable because on a calculus you have a base e, but also we already know how to take the derivative of logs in base e. And in fact, this over here, remember how I said that log base e of 2, like what actually is that? That's actually just a number. It's a constant. You can actually put that in your calculator and you can get some number out, right? So another way to write this is, hang on, if this is a fraction, I can write this as 1 over log base e of 2 times log base e of x. Now can I find the derivative of this? And these two are the same thing, right? So what I've done so far is, hey, all I've done is say, is there another way I can write the log base 2 of x in a form which I can differentiate? In order to differentiate, we need to have it as base of e, which, Carl, using the change of base formula, you've done, right? So we do that, and now I have this here, log base e of x over log base e of 2, and all I've done is say, well, this is just a number, right? So I can kind of bring that out as a coefficient here. I've got 1 over log base e of 2 multiplied by log base e of x. Now can I find the derivative of this expression? Using my normal derivative laws. Yeah, what would I have to do?
Log base e of 2 becomes 1 on 2 because of if you go back the dy dx.
Okay. Be careful though. Remember saying that this, what did I say this was? Like, you can actually put that in your calculator. It's actually just a number, right? So if you ever have like, remember when you have like 5x and you take the derivative, you just get it with 5, right? Because the constant just stays there, yeah?
You can go back to that.
Yeah.
Y equals uv.
Yeah.
And put it into that formula.
In this product rule form, what do you guys reckon?
I disagree.
Why is that?
Because it's a number.
Okay, so this is where we need to be very comfortable. This is not just for logs, this is for any derivative, okay? What's the difference between a constant and a function, okay? Because for the product rule, whenever you have two functions multiplied together, both in terms of x, that's when you need to use this. So we had to use it for this one, because you can see you've got x times log base e of x. These are two functions multiplied together. You can't just take the derivative of one and take the derivative of the other and then put them together, yeah? But if it's just a constant, if it's like 5 log base e, right, can you see how we just leave the 5 there? It just stays there. Right, and what did I say about this guy? Yeah, this guy's just a number. We actually just leave it there. We don't have to touch it, Carl, yeah? So we just leave it there, and then we differentiate, Harry, log base e of x. If I take the derivative of that, we actually looked at that one earlier. What's that going to be? We did, yeah. Check back in your notes, man.
Oh, 1 over x.
1 over x. So this is just going to be, remember the constant stays there. Right? So then we can put that all under 1. X log base e 2. So as a general form, we can say that if y is equal to log base a of x, and then our derivative dy dx is equal to then 1 over x log e of the base. You see that, right? Because what happens is, after you do the manipulation algebraically, what you get left with is, well, you just essentially taking the derivative of log of x, which we know is already 1 on x, and so that's always going to be there. What's different is if the base is different, that's still fine, you'll just change this value.
Are you sure? Yeah, look.